Good morning, girls. Today we have discuss about group theory. The first group. So, what is group? A group is a set of distinct elements G, which is equal to E, A, B, C, D, etc. So, which is finite or infinite in numbers, endowed with the law of composition, such as addition, multiplication, matrix multiplication, etc., such that the following properties are satisfied. So, first one is closure properties. The composition of any element A and B of a group G under the given law results in an element which belongs to group G. Thus, A star B belongs to group G means B star A also belongs to group G. Here, A and B, both the elements which is in group G. So, next one is associative. The law of composition of a group elements is associative. For example, for any elements, here we consider an element A, B, C. So these three elements belongs to group G means A star B star C, which is equal to A star B star C, belongs to G. So all the elements belongs to G. So next one is identity element. The group contains an identity element E such that for all elements A belongs to G. So here A star E, which is equal to E star A, which is equal to A. So both the elements A and E belongs to group G. So E is an identity element. So next, inverse of an element. For any element A belongs to group G, these elements an unique element. So here we consider an unique element as B such that A star B, which is equal to B star A, which is equal to E. So the element B is called an inverse of an element. So with respect to star, so so here we have written B as A inverse. So which is write B equal to A inverse. So next abelian group. So abelian group is nothing but a product of a group elements is not necessary commutative, but the elements all the elements of a group commute with each other is said to be an abelian group. All the groups all the groups are said to be abelian except the group of all non-singular square matrix of order n or abelian groups. So here we consider, so simply we have tell us the abelian group is nothing but the elements in that particular group are commute to each other is called an abelian group. So A star B, which is equal to B star A. So both A and B belongs to group G. So some of the examples of a group. So the basic examples. So first, the group of order 1 consists of an element E alone. So which is an identity element. So the group of order 2 consists of an real numbers. So for example, 1 and minus 1 with ordinary multiplication as the law of composition. The group of an order 4 consisting of complex variables. So that is a complex numbers. So plus or minus 1 plus or minus I. So I plus or minus I means I square, which is equal to minus 1 under multiplication. The discrete infinite group of all real numbers. So that is positive numbers, negative numbers, and also zero under law of composition in addition. So the identity element of this group is zero. The continuous infinite group of all real numbers under addition as the law of composition. The identity element of this group is zero. And the inverse of an element x is its negative minus x. The set of next one is the set of all positive real numbers. So excluding zero. Under multiplication, the identity element of this group is 1 and the inverse of an element x, which is written in a reciprocal format 1 by x. So next one, the set of two matrices. So should be in matrix multiplication. So here, the set of all 3 by 3 matrix with the real entries of a form is a group. So the group is sometimes called as a Heisenberg group. Okay. So the set of all non-singular next property. Next example, the set of all non-singular square matrices of order n being a positive integer under matrix multiplication. So these are some of the examples of a group. So next, order of a group and order of a element of a group. So order is nothing but a number of elements in a group is called order. The group containing a finite number of terms is called finite group, and a group containing infinite number of terms is called infinite group. And group an infinite group may either be discrete or continuous if the number of elements in a group is denumericably infinite, such as integer. So sum of positive, negative, or zero. The group is an discrete, and if the number of elements in a group is non-denumericable, so infinite, such as real numbers, so the group is continuous. So the order of a group is nothing but a number of elements in a group is called order. It is denoted by O of G. An infinite group is a group of infinite order, and finite group is a finite order, is in a finite order. So some of the examples, let G equal to, so these examples we have discussed in the examples for group. Okay, so here also the examples given. So we have already discussed these examples. So the group of order 4 consisting of a complex numbers. So complex numbers, which is means the plus or minus 1 plus or minus I. So I square is equal to minus 1. So minus 1 square equal to 1. So order of minus 1 is equal to 2. So I power 4 equal to 1. So order of I equal to 4. So I minus I power 4 equal to 1. So order of I equal to 4. So the additive group Z equal to, so minus 3, minus 2, minus 1, 0 up to 3. The order of 0 is 1 finite. So here n a not equal to 0 for any non-zero integers a. So order of a is infinite. Thank you, girls.